Now, where does all this energy go when you take a form of transport? What's happening to the energy? Why do the different forms of transport use the energy they do? Well, basically there are three major places the energy goes. Kinetic energy, starting and stopping, rolling resistance for land transport, and drag or wind resistance for almost all forms of transport, and we'll go through them in turn. So kinetic energy is stopping and starting. Basically, every time you take a method of transport and speed it up, you have to put energy in. When it then slows back down again, let's say imagine it's a car, normally you slow it down by putting on the brakes, and that kinetic energy is converted into heat in the brakes. So what you're doing is you'll burn fuel to accelerate your car, and then it'll go into heat as you decelerate. So basically it's wasted. This is a problem when you're stopping and starting a lot, when your form of transport is heavy. So it's a big problem, for example, for urban driving. Driving in a city, you're starting and stopping, there are traffic lights, there's traffic jams, there's corners you have to turn around, so you're taking your 1.5 tons of car and accelerating it, then slowing it down, then accelerating it, then slowing it down, then accelerating it, then slowing it down. It's also a problem, for example, for urban trains. They're always speeding up, then slowing down to the next station, then speeding up again. It's not really a problem for long distance trip like driving to Sydney or a high-speed train or a plane for long distances. But in cities, it's a major source. What can we do about it? Well, you could have a lighter weight vehicle, so you don't have to put so much energy every time you speed it up. This is one reason why bicycles are so efficient. But if you do have a heavy thing, you can use regenerative braking. This is what hybrid and electric cars and many suburban trains use. Instead of having brakes to slow yourself down, you actually run the electric motor in reverse, so you turn your motion into electricity to recharge your batteries. And this can certainly make vehicles much more efficient. This is why one of the major reasons why in cities electric cars and hybrids are much more efficient than petrol cars. Another way you lose energy is rolling resistance if you've got wheels. Whenever your wheel turns, it bends, it squashes at the bottom a bit, and that uses up energy. You're constantly squishing a different part of the wheel as it rotates. So this applies to all wheeled vehicles. And basically, how much energy you lose depends on how squishy your wheel is. So if you've got your bike tyre or your car tyre that's not very well pumped up, you're going to be losing a lot of energy. And this is often about neck and neck with the starting and stopping energy for urban driving. So it's probably 50-50, half the energy is wasted by rolling resistance and half by starting and stopping. Similarly for long distance driving, about half of the energy in a car is wasted on rolling resistance and about half is wasted by drag that we'll talk about in a minute. So what can you do about this? Well, pump up your tyres properly. If you pump them up too much, they might burst and they might damage the road, so there are limits on that, but nonetheless, a properly inflated tyre means you use a lot less energy. The best way to do it would be to have metal tyres that don't bend at all. That will give you a very bumpy road and really chew up the road, but maybe you put metal tyres on a metal track, and that would be very efficient, and indeed that's called a train. And that's one reason why trains are more efficient than cars. And then finally we get to wind resistance or drag force. Assuming you're travelling not in a vacuum but through an atmosphere or through water, you have to push the air out the way as you drive or push the water away as you swim. And that takes energy, pushing all that fluid out the way. The energy needed depends on the cross-sectional area. Pushing something big through water takes more force than pushing something small. It depends on the density of the fluid. It's much harder to push water out the way than air, which is why ships are inefficient. How streamlined you are, but most of all it depends on the speed, because the power needed to move through a fluid, the drag power, is proportional to the velocity cubed, so going faster makes it much worse. So drag basically is the dominant source of energy wastage for anything that's going fast, like planes, highway driving cars. It's also a dominant force for pushing through something really dense like water, so it dominates for ships. Whereas if you're driving slowly in a city, then it's not so much of an issue. What can you do about it? Well, one way is to have a very streamlined car with a small cross-sectional area. So the Tesla Model 3, that's my family car, has a very low drag coefficient, and it's a very low-slung, streamlined car. So that helps. A lot of people don't like low cars, they like a high car, so they sit up high in an SUV. Um, but if you make the car very streamlined and very low, so it has a low cross-sectional area, that will certainly help. You can also get air resistance down by going slowly, but that's probably unpopular. You can make your form of transport very long and thin, so you get lots of people with only a small cross-sectional area. This is called a train. This, for example, is a Japanese bullet train, and you can see that its cross-sectional area is bigger than a car, but you get a lot of people hidden behind that area, and it's very streamlined. So this is one reason why high-speed trains are good, very streamlined, long and thin, and metal wheels on a metal track. Or you could even go for maglev or something like that, where there's actually no rolling resistance. Another way to reduce drag is to reduce the density of the air. One idea that's been floated is the Hyperloop idea of Elon Musk, which is to have a maglev train that runs inside a vacuum tube. You have a very large tube, you pump the air out. Of course, you need an air supply in your actual train so you can breathe. But then if you're travelling down a vacuum tube, you can go extremely fast and very efficiently. And the estimates are this is probably the most efficient form of transport for distances of below 1,000 kilometres. But you have to build a whopping great vacuum tube. Another way to reduce the air density is just to go high. Aircraft typically cruise about 10 kilometres up, and there the density of the air is only 30% of the density at sea level. So that will help you quite a lot. And that's one reason why over longer distances, like over 1,000 kilometres, aircraft are often the most efficient form of transport.